The topic for this video is the periodic table. The essential questions are: can you predict any properties on the periodic table by the position of the element? Periodicity is basically having trends, and trends are properties that change. We're going to talk about today atomic radius, ionic radius, ionization energy, and electronegativity. A group trend is a change from the top to bottom down a group, going vertically, and a periodic trend is a change from left to right, going across the row. First, we're going to talk about the atomic radius, which is the size of the atom, just like the radius of a circle indicates the size of a circle. So here's a picture, and this shows you an actual size relative to each other. Obviously, atoms are way too small for us to see. So the group trend is that they are getting larger down the group, and you can see that if you look at the picture. This is because we have more energy levels, which makes the atoms larger. If we take lithium, for instance, it has 2 energy levels because it's in the second row. Potassium is in the 4th row and has 4 energy levels. So it's getting way, way bigger as it goes down the group. The periodic trend is it gets smaller as you go across the row. This is because you're gaining more protons. Each step you take, you get another proton, and that pulls those electrons in closer. Remember, protons have a positive charge, and so electrons have that negative charge. They're attracting each other, and they're pulling the electrons closer, and they are not gaining energy levels. If you look at lithium, it has 2 energy levels. It has 3 protons. Carbon also has 2 energy levels, but now we have 6 protons. And neon still has 2 energy levels, but now we have 10 protons in there. So it's pulling that much more on the electrons to pull them in closer, making it smaller. So if you have to arrange these atoms from smallest to largest, you need to take into account both the group and the periodic trend. So your teeniest atoms are going to be in the top right corner, and as you go diagonally down and to the left, they're going to get bigger. So the one in the most top right corner out of that list is neon. Then the next one is sulfur. And the next one we come to as we move down and to the left is aluminum, followed by calcium, and then strontium is last, making it the biggest. Okay, the next trend we're going to talk about is the ionic radius. This indicates the size of an ion. An ion is an atom with an electrical charge, which is plus or minus, and we're going to be talking about those a bunch in the units coming up. A cation is a positive ion, and it forms when an atom loses an electron. And cations tend to be smaller than their atoms. You can think about they're losing a particle, so they're going to be smaller. Sodium has an electron configuration of 3s1, and that's the one that goes away. So it loses a whole energy level when that goes away, and the same number of protons are there, so they're pulling on fewer electrons. And again, we know that tightens up the size. Anions are the opposite. They are negative ions, and they're formed by atoms gaining electrons. Anions are bigger than their neutral atoms, okay, because they're gaining more electrons and you still have the same number of protons pulling on more electrons, they're not able to pull as much. So the group trend on an ionic radius is that they get larger going down the group, the same as the atoms. Okay, so this shows you again the relative size this time as ions. They're getting bigger and bigger. The periodic trend is a little weird. It gets smaller as you go across, but then it gets bigger at group 5A, and then it gets smaller again. Okay, so that's a little bit weird, but you're just going to have to remember 5A is where you see a big increase and then it gets smaller again. So if we arrange these from smallest to largest, again, we're going to have to take into account where they are. So calcium is going to be smaller than potassium, then bromine, selenium, arsenic is last. Okay, for ionization energy, it's the energy required to remove an electron from an atom. Okay, so the group trend is it decreases going down, and it's because the larger atoms don't have as much a hold on those really outside electrons. Okay, so we have lithium again, and its protons are right next to its electrons, and then you have potassium again, whose electrons are a little bit further away, so it takes less energy to take that electron away from potassium than it does from lithium. The periodic trend is that it increases going across, and it's for the same reason. The protons have a tighter hold on those electrons, and so it takes more energy to take them away. So if you look at sodium, which is on the left, holding its electron compared to aluminum, holding its electron compared to chlorine holding its electron, you can see that the electrons are getting closer and closer to that nucleus where it's being held on. So it's going to take more and more energy to get rid of it. So sodium is going to be by far the easiest one that requires the least amount of energy. Okay, so if we think about which one will lose an electron the easiest, potassium or germanium, it's going to be potassium because it's further to the left. Magnesium or barium, it's going to be barium because it's further down. So it's a bigger, you're looking for the bigger atoms. Aluminum or cesium, it's going to be cesium because it's further down and to the left. Electronegativity is the number. It's a number from 0 to 4 that indicates an atom's attraction for additional electrons besides the ones that it already has. Okay, so fluorine has the most. It gains electrons really easily, and it's also really reactive. Cesium has the least, but that also means it's really reactive because it's going to lose its electrons really easily. So the group trend is that it decreases going down. Okay, and the periodic trend is that it increases going across. Until you get to the noble gases, they don't have any electronegativity at all. Okay, the reason for this, you can think again about the size. As they go down, they get bigger, so they're not going to attract as many other electrons because they're not going to have that pull. As you go across, the size gets smaller because they are having more interaction with their electrons, so they have more pull. So if you have to arrange these from greatest attraction to least, they're going to have the greatest attraction in the top right corner and the least attraction in the bottom left. So we're going to go in that order. So the trend summary, the smallest radius is in the top right, the largest radius is in the lower left. The highest ionization energy is in the top right, the lowest ionization energy is in the bottom left. Highest electronegativity is top right.